shoes and out the door. 5, I'm alive. 6, 7, 8, feeling great.
Hello, BYWG tribe. Here is a quick peek at our supplement, product, and book of the month for February 2020. At the end of the podcast, I will spend a few minutes going into further detail, so we encourage you to listen to the end. The supplement of the month for February 2020 is Vitamin D3 Boost. This is our newest advanced formulation, combining all the benefits of vitamin D3, vitamin K2, magnesium, and MCT oil. The 10% discount code for the entire month and it's all lowercase, VITD10. The product of the month for February is Joovv, red light therapy devices. I personally own the Joovv Mini and Joovv Go and use them both daily. The book of the month for February is Cancer and the New Biology of Water by Dr. Tom Cowan. Hands down, my personal favorite book of 2019. Keep in mind, all the links, discount codes, and special offers for the product, supplement, and book will be listed in the show notes on iTunes, posted on social media, and a weekly newsletter, and on our website at www.beyondyourwildestgenes.com at the Listen.
Absolutely. Yeah, I started very allopathic trained in many ways, but actually got my debut at the beginning of life, I guess, as you would say, in that I was going to be an engineer and then happened to choose to do some time abroad before I went to undergrad, and spent time in the Philippines for 6 months living there and working with a group of international midwives delivering babies, and that was kind of my intro to medicine, and just couldn't resist the opportunity to get engaged when I got back, and shifted back into pre-med rather than the engineering route. And that experience in a lot of ways kind of planted some seeds in the back of my head as far as how extraordinary natural childbirth could be, how extraordinary kind of a non-pharmaceutical approach to health could be. And then it got put on the back burner, and I very much got seduced by the pharmacologic model. I went through University of Colorado, got my MD there, internal medicine bound. I went to University of Virginia and got my 3-year medicine specialty there, and then went on to a year in chief resident year, which is basically teaching on faculty there, teaching med students and residents. And then went ahead and continued my education at that point, in large part because I really felt like I was unequipped to get to that root cause of what was driving the disease that was so common in my patients. And so I went into endocrinology, which seemed like kind of a good approach to getting to the root cause of everything, because as the endocrinologists say, everything is endocrinology because everything has to do with communication. And so dove into the world of hormones and this incredible world of the mitochondria. Mitochondria, as you know, are kind of like bacteria, except they live inside of our cells instead of outside our cells, and they replicate irregardless of what our cell is doing. They can also die quickly with toxin exposure and the rest. And our longevity, which is a big thrust of your program here, is really tied to the health of these guys. And so in that arena of the mitochondria, I ended up finding a new path for my basic science research, which had previously been interested in mood disorders, mental health, neurologic conditions, and ultimately how the brain could be plastic with its environment. And so that field of neuroplasticity was coming of age. This was the late 90s to the early 2000s, and I was kind of a major interest in mine as how the hormones were changing the way our brains wire throughout life, and also in disease situations like major depression or anxiety disorder. So that was my first journey into the basic sciences, and then dove into this world of mitochondria and realized that the endocrinologist would probably have a lot to offer in the world of cancer management. And so I started doing some basic science research, which ultimately led to the development of some chemotherapy compounds for metastatic and aggressive tumors involving the pituitary gland, brainstem, etc. And so that was kind of my allopathic journey. The shift happened when my patients started bringing me books on how they could reverse their diabetes with nutrition. And I had trained at the third best endocrine program in the world, and nobody had ever mentioned that you could reverse type 2 diabetes with diet alone. And so it was an aha moment for me in this allopathic bubble that I lived in, and tore through a book that my patients had given me, Neil Barnard's program for reversing diabetes. And that was a huge huge opening for me. Suddenly realized I hadn't been taught anything terribly interesting about health, and all of my education on disease management, I had already kind of proven out over the previous 6 years that it was a chasing after the wind. So as I was in my last year of fellowship in endocrinology, I started to dive into the science of nutrition further. Ultimately, as I went on to faculty UVA, tried to get underway with a nutrition clinic there to reverse chronic disease, and was unsuccessful. There was a number of different barriers, ironically, including the dietitians in the university, as they had been trained through kind of the food pyramid approach to teaching nutrition, and the data that was coming out at the time was really suggesting that a plant-based diet was going to be the right approach. So watched with somewhat of awe how much not only a lack of education we get in nutrition, but the nutrition we do teach in these academic centers are steeped in dogma that really dates back to legislative farm bills and marketing campaigns from the food industry, and just very little science behind this dogma that we have in the nutrition field. So left in 2010, started my own nutrition center in Virginia, and that's where I am today in a lot of ways. I've got a busy clinic and a lot of research and development, have my own biotech companies now, and we've launched, as you mentioned, the dietary supplement Restore, which has gone international and has become a phenomenon just due to its kind of root cause here. As you go down through the root causes, you're eventually going to find yourself in the dirt, and that's where we found ourselves.
So, why don't you continue there? Why don't you talk to us a little bit more about dirt, because that's where you found yourself. And as I mentioned, I listened to many of the podcasts you've been on in the past, and I'm fascinated by how you connected all the dots of all your different education to get to where you are in your product today, which is called this Restore. So tell us a little bit about dirt.
Yeah, so I almost have to back up a little bit to even tell that story, because I was the last guy you'd ever think would care about dirt, except that my research had started diving into this area of mitochondria, and there was a lot of agreement in the entire field of cancer that cancer is a genetic disease. Except at the time we were seeing this huge explosion of the rates of cancer in our country for the first time, and it was actually starting to approach the disease rate and death rate that we see with cardiovascular disease, which had always been king. And so there was something afoot that was starting to really question and call into question my training and dogma that I had in the world of cancer. And some of the cracks that were happening in that glass ceiling of the philosophy in the mid-2000s was that there was a number of studies coming out of the University of California, San Francisco, and UCLA, UCSD. All of these universities were starting to publish data around genomics. And I know there's a big thrust of your podcast here is the story of epigenetics. And as we had been able to start to tease out the human genome in the 1990s, we suddenly realized that we're really simple creatures on the genetic level. At least it appeared to be, because at the time we thought that genes kind of ran the show. But humans only have a mere 20,000 genes, which is pretty pathetic compared to what we knew at the time, which was that the flea, the little tiny insect, has a genome of 30,000 genes. So it was really mind-boggling that the human could be 2/3 as complicated as a flea, and only slightly more complicated than a fruit fly, which has 13,000 genes. And so this world of epigenetics started to emerge out of necessity, because it was suddenly clear that one gene does not make one protein, and therefore something much, much bigger must be afoot. And that led to the discovery of epigenetics, which, as most of your listeners probably know, is kind of how genes turn on and off by this methylation pattern that can happen when different environmental exposures happen. So you can turn off a gene or turn on a gene based on your environment. But it was still not answering the question of how a single gene could make over 200 different proteins depending on its environment. And so the genome projects kept expanding, and we were studying more and more on the human genome. We were starting to decode a lot of non-genomic information that was not coding for genes in the human. We were starting to realize, eventually that 99 or 98.5% of the human genome all of its genetic information in those base pairs is actually what we call junk DNA. It did not code for a gene. So not only are we super simple with these 20,000 genes, it only accounted for 1.5% of our total DNA. And so this was starting to lead to massive questions as to what is the origin of life? Is the DNA really the secret to everything? All of these major questions, which has to this day stayed pretty quiet in the mainstream media. Mostly, I believe, because there's been a huge suppression of any major questions towards this kind of DNA hypothesis and genomic hypothesis that's kind of been the dogma in the cancer realm and beyond. Nonetheless, teams started to turn their attention away from the human genome at this point to see if answers laid without, and what they started to find was that they were starting to see very definitive patterns in the genomics of the microbiome of the gut. And so the microbiome is not just bacteria, but also all of the fungi and ultimately viruses and parasites and the whole massive ecosystem that lives within us and on us and ultimately even in our tissues of our body, not just in the gut. And so this DNA, sleuthing that was going on to determine kind of what was going on in the gut started to show patterns that if you had a certain species of bacteria missing from that bacterial or microbiome genetics, you would predispose that individual to a certain cancer. So if you were missing these bacteria, you might get breast cancer. If you were missing these bacteria, you might get colon cancer, etc. And so that reality of the microbiome somehow patterning what we had, heretofore really believed was a genetic disease was really radical and was really being laughed at, frankly, in our tumor meetings in, the mid-2000s. But by 2010, 2012, it was starting to get really unavoidable in the literature that, wait a second, this microbiome somehow is really affecting the human genome in a huge way. All of this led ultimately to the major discovery of the microRNA, which is an interesting story. The microRNA is kind of the next step beyond epigenetics as we had seen it. MicroRNA actually are tiny little sequences of RNA that are coded from the junk or non-coding sequences of DNA that account for the 98.5% of your genome. These microRNA are so tiny that they were really undetectable until, just in recent years, we developed the ability to find these and measure them. And the awesome thing that we're finding right now is that not only are these things extremely good at modifying the gene behavior in your body, they're extremely mobile. And by mobile, I mean that they can not only leave the nucleus and go into the cytoplasm of the cell where all your messenger RNA go, they can leave the cell and go great distances. They can go into the bloodstream, they can travel from organ to organ, covering large regions of the body, but perhaps way more exciting, that these guys can actually leave your body. And so the microRNA that are being coded from your non-gene DNA is now seen to be going out in your breath, in your saliva, in your urine, your feces. You're like exuding this stuff into the world around you. And by so doing, you're affecting the genetic decision-making in the organisms around you. And likewise, we suddenly had an understanding of the fact that, wow, down here at the foundation of the genomics, we can see this, manipulation of the human genome happening by the microbiome that lives within us. Their junk DNA, their microRNA, starting to affect the way in which your genes turn on and off. And this was a big step towards understanding how, missing bacteria in your gut could predispose you to systemic disease such as cancer or autoimmune disease or the rest. So that was, some of the major steps that were leading us down this belief system that, okay, the gut is beyond critical. It's beyond the fact that, 80% of Americans identify themselves as having some sort of gut problem, whether that's heartburn or irritable bowel syndrome or gut sensitivity to their food or whatever it is. Huge percentage of us are now experiencing an upset gut. And so it was clear that gut was important, but this took it to a whole nother level that, man, we cannot even express the genes in a healthy fashion if our genomics are off in the gut. So, to kind of take that next step then, is, okay, if the bacteria are important and we suddenly have a chronic disease epidemic, how did all that happen? Well, why are we we dying? Why are we, accumulating this rate of chronic disease that's never been seen in history before? Our children have 46% with diagnosis of a chronic disease by the time they're age 18. And so that's an extraordinary statistic because just a few decades back, the entire U.S. population, cradle to grave, only had a chronic disease burden of about 4%. So to go from 4% to 46% in just a short few decades was an extraordinary reality. And so what is it that we did to our environment that could have so decimated our foundation of the microbiome? And that started to take us down the study of what are the farming practices currently and what's going there. And it was our chief science officer, a PhD, John Gilday, brilliant man, who kind of made the first mental leap to say, I think that we've got Roundup in the mix here. And Roundup is kind of the most ubiquitous weed killer that's been used in American agriculture, and then it became the foundation for the genetic modification of crops so that they would be Roundup ready or be able to tolerate direct spray of this chemical. That chemical started to really take off in the 1990s with the advent of GMO corn and soybean in 1996, going public with that. And then by 2002, 2004, we saw, some 90% plus of our corn in the country being grown GMO, and 85% of our soy. I'm sorry, I got that reversed. 85% of our corn and 95% of our soybean all being genetically modified. So with that, we were suddenly able to directly spray our crops with this pesticide herbicide. The interesting thing about this compound, it had never really been patented as a weed killer. Instead, it had been patented multiple times as antibiotic, antiparasite, antifungal, all kinds of compounds that it kills. And that was kind of now putting all the pieces together. What if in the mid-1990s we started to spray all of our food and therefore all the soils in which our food was grown with a chemical that was blocking the ability of bacteria and fungi to survive. And so we were spraying our crops and soils with an antibiotic. This then led to a collapse of the genome and the microbial life within our gut. And this was a direct consequence of the collapse of the genome and the microbiome in the soil. As the soil was getting drenched with antibiotic and our food was getting drenched by antibiotic, the bacteria in both places, both the soil and our gut, would be decimated, just like any other antibiotic exposure. The difference, though, is that this was an insidious, add of antibiotic through our food that kept growing over the next 15, 20 years. And so it was kind of this insidious process rather than a dramatic, 7-day course of antibiotic. This was a low-grade exposure to antibiotic for years and years and years that grew and grew over time as we grew more and more genetically modified crop, as we more and more saturated the environment with Roundup. So that's kind of ties, I think, answers that question perhaps to how did I get interested in soil. In some ways, it all comes back to genomics, the genomics of the microbiome, both in the soil and your gut, predicting exactly what your genes are doing, what oncogenes or cancer genes are you turning on, which, anti-cancer genes are being turned off and all of that. So what would that scenario look like?
Yeah, you basically asked my next question, and I'm going to ask it even though you answered it, and I'm assuming so. What do you believe is one of the prime causes of ill health, decreased immune function, and the destruction of our collective microbiome? I would assume you would say Roundup or the chemical in Roundup, which is glyphosate, correct?
Yeah, glyphosate is definitely one of the major players of the last 20 years for sure. And my confidence has certainly gone up in that as we've continued to study this over the last 7 years in our labs. Arguably, we've done more glyphosate research than any other lab outside of Monsanto, I think. So we've really looked carefully at what are the mechanisms by which this chemical is interacting with the gut lining, and how could that possibly predispose us to all of this disorder and disease. And the answers are pretty profound at the microscopic level. The answers, number one, it's in Monsanto's own patents that this is an antibiotic, it kills bugs, kills plants through the same mechanism of action. But what they don't go on to say is that there's any human targets. In fact, they seem quite adamant in their marketing and in their paperwork to the EPA over the last 35 years is that it doesn't hurt the human directly. It only hurts bacteria, fungi, and plants. I don't know if they've just never studied this. To say that they've never seen toxicity in human cells, in our experience, that would suggest they've actually never looked under a light microscope at human cells that are growing in the presence of tiny amounts of Roundup, because at very tiny amounts, this thing radically changes what cells look like under a microscope. And the main, detection that we're having at this gut is the function of the gut membrane. So this huge gut barrier system that is made up of a trillion cells of these microscopic epithelial lining cells of your gut that run from your sinuses all the way down to your rectum. This is your front line of defense to the outside world. You want to keep in mind that the outside world, is got all kinds of chemicals way beyond Roundup here. So I don't want to say that all of our chronic disease is from one chemical. I think there's a perfect storm going on.
Right.
But what I'm about to describe is that we're really tearing the foundation of protection out of your body by this one chemical, and then everything else, I think, becomes far more toxic. And so with the active ingredient Roundup being glyphosate, this chemical has this direct ability to break down the Velcro-like tight junctions that bond all of these trillions of cells into your protective gut membrane. Your gut membrane barrier is quite huge. It's notable that it's much larger than your skin, which is your other source of exposure to the outside world, obviously. Your skin has somewhere around 1.5 meters square of surface area, whereas your gut lining has somewhere between 1 to 2 tennis courts in the surface area. And so you have this massive exposure to whatever goes in your mouth, whatever you breathe in, all of this exposure constantly. And it's engineered seemingly very poorly. I tend to over-engineer everything I set out to do, so I miss the eloquence of nature's design. Nature's design here put that huge two tennis court surface area down to just half the diameter of a human hair in thickness. It's one cell layer deep. And so at half the width of a human hair, that cellophane-like layer that keeps you separated from the outside world needs a backup plan. Because if that membrane starts to get damaged, the outside world's about to come inside. And to manage that, the human was engineered with this 60 to 70% of our entire immune system sitting right behind that thin membrane that separates you from the world. That immune system there makes over 80% of the antibodies that will go on to protect your body from the outside world. The dilemma happens when the membrane starts to really break down at large, not just like a spot weld failing here, a spot weld failing there. Suddenly the whole thing turns into a leaky sieve, and you're getting immune system activation across the whole board. Now suddenly with time, your body starts to lose reference to what's outside and what's inside. Suddenly everything starts to look like it's inside, and you start reacting to everything around you. One of the interesting consequences to this, of course, is the autoimmune diseases. If your body keeps reacting, it's not going to be long before one of your antibody-producing cells, called the B cells, which are driven by the T cells, start to recognize self as the enemy. And I think we do this mentally all the time, right? We're all our own worst enemy, is the old adage. And I believe that's true emotionally and intellectually and all of this. But there's something deeper going afoot now, that we're all becoming physically our worst enemy as we lose this gut barrier system and we start to ramp up chronic inflammatory events throughout the gut, and we increase with every passing week or month that we leak a likelihood of having one of these autoimmune disorders develop. And so it's an extraordinary story of one chemical that's damaging the Velcro between our cells to create this huge leak across this cellophane layer from the outside world, and suddenly we're in an overwhelmed state with our gut lining.
So I know this leads to you discovering a set of molecules that essentially helps to, quote unquote, restore this lining. And I absolutely want to get there, but I have a few questions that I want to ask leading up to that. Most of our audience is aware of, the benefits of probiotics, prebiotics, specialized diets, but why are these things simply not enough to get the results that we want in our microbiome, in our health, in our gut health, in our immunity.
Excellent. So this goes one layer deeper than the epigenetics, and this is where I'd gotten to in my cancer research, was the fascinating reality that, all of the genomics with the bacteria talking to the human cells, turning on and off oncogenes, turning off, cancer suppressor, cancer activator genes, all of this talk had yet another underpinning, and that was redox signaling molecules. The word redox refers to reduction and oxidation. Reduction is the donation of an electron in a biochemical reaction, and oxidation is the tearing away or absorption of an electron. And so the place in which we first discovered this was nitric oxide. I'm sure you guys have had podcasts on nitric oxide, I suspect, but it's the only redox molecule that's made by human cells. And so the redox molecule made by the endothelial layer that lines all of your blood vessels produces and reservoirs nitric oxide, which then can be released into the bloodstream once you start working a muscle to hypoxia. Once you start to get a little ache in the muscle from repetitive motion or exertion of a muscle body, then you'll dilate the blood vessels and deliver more oxygen through the delivery of nitric oxide. And so that was kind of the first discovery. This is the early 1990s. A gentleman who found nitric oxide ended up winning the Nobel Prize for that one. Then in the late 90s and early 2000s, we started to get the realization that all of these reactive oxygen species coming out of the mitochondria might actually be doing something. We thought previously that these were just dangerous waste products that were highly oxidative or dangerous to the inside of our human cells and need to be cleared quickly by the antioxidant system. Well, it turns out that we were wrong. It turns out all of these molecules coming out of the mitochondria are largely, especially when you have a healthy cell cranking these out, a communication network to regulate everything from cell metabolism to cell turnover to apoptosis, which is programmed cell suicide. It's all of these extraordinary major events were taking place not by genomics, but by the electrical communication through these redox molecules coming out of mitochondria. And so that was my area of expertise in cancer. With the chemotherapy I was developing, I was able to turn on apoptosis or programmed cell suicide with no immune system to address the cancer cells. Instead, the cancer cells, with enough information from a redox signaling environment, would simply turn on apoptosis or suicide and kill itself. So that was a very exciting new realization that we could go deeper than the genetics. We could go back into cell function by simply getting communication restored at this redox signaling environment. The issue with redox signaling, though, from the mitochondria is that it's very, very ethereal. It's very sensitive. It needs to be in a very, very controlled environment, which is, fortunately, the way in which the inside of your cells are. Insides of your cells have a very controlled pH, osmolality, electrolyte balance, etc., etc. And so that reality is really important when we start to think about the outside of the cell. The outside of the cell with all of these connective pieces, the tight junctions we mentioned earlier that keep a huge membrane like your gut or the lining of your blood vessels all intact, that's not within the cell. And so we had never really pictured redox signaling happening outside the cell. The typical redox molecule coming out of a mitochondria only lasts for 1/1,000,000th of a second. This is down at the quantum physics realm of crazy here. But these redox signaling molecules pass an electron through their transitions of electrons with hydrogen and oxygen binding, and it's like a domino chain, but each domino only lasts like 1/1,000,000th of a second. And so that's a very ethereal, signaling system that's very vulnerable to pH change, etc. And so when you go outside of the cell and you no longer have this controlled environment, it was almost impossible for us to visualize something that could do redox signaling or this biochemistry communication outside the cell. And then it was just sheer accident. I don't think anybody is smart enough, whether it was, the Einsteins of the world or before, nobody goes into a paradigm shift in science proactively thinking, I'm going to create a new paradigm and this is how I'm going to do it. Instead, it's always a bumbling, accidental, total chaos, maybe asking the right questions, but usually asking a question that you accidentally get the wrong answer to, and that wrong answer ends up leading to the right question that you should have asked before. And that's what happened to me. And so we were certainly asking all these questions about the gut. How come our patients are not getting better on the healthiest foods in the world? How come they actually look like oftentimes are getting worse on health food, not better, like what's going on at the gut. And so we were diving into soil science for the first time in my experience, and in a white paper, we were flying through it, and on page 40 is this huge molecule that suddenly, it's just one of those moments where all of your training, all of your stuff comes to its moment of purpose. And the three-dimensional structure, this was a two-dimensional drawing, but through repetition in my cancer research, I was seeing this molecule in 3 dimensions, and the three-dimensional structure looked a heck of a lot like this redox signaling capacity that's needed down at the biochemistry level when you're dealing with cancer cells. And so to see this in soil was extraordinary, but the most goosebump moment is that on the back of this three-dimensional cluster of oxygen and hydrogens is a huge carbon backbone. And that suddenly was the lights kind of going on of like, oh my gosh, what if there was a stable redox molecule that could live outside of the human cell? What would that do? Wouldn't that be an extraordinary boon for this extracellular environment and ultimately signaling from the outside world into your mitochondria, into your nucleus and your genomics and all of that? And so that was the aha moment. When we later found out that those molecules were being made not only in abundance but in huge diversity by bacteria and fungi, it was kind of the moment of crystallization. It turns out that bacteria and fungi, especially the bacteria being single-celled organisms, they do not have mitochondria in them. And so without mitochondria, it'd be impossible for them to make the typical oxygen-based redox signaling stuff that we kind of think of in the human biology. And they are constantly having to communicate outside of themselves. As a singular-celled organism, there was no intracellular communication. It's all extracellular. And so it made sense that if these guys were going to have a redox pathway to exchange electrical charge between species and beyond, they were going to have big old carbon backbone to keep that thing stable. So that was the discovery. As we started to kind of go down the avenue of trying to figure out, well, does one bacterial species need this or make this, or is it everybody? It increasingly became clear that the entire microbiome is making some niche within this huge communication network of these carbon molecules. We now call these carbon snowflakes in the lab because everybody's kind of familiar with the fact that, oftentimes each snowflake falling on your hand is going to have a different crystal structure to it. And that's very much like these, each species making their own subset of 10 or 15 variants of these carbon-based molecules that have the potential to release hydrogen and absorb hydrogen to give this kind of redox potential too. So I think that where we stand there is, I can give you a little bit more background on some of the steps we went from there. The next steps were to figure out where we were going to get this in abundance. We needed a large amount of this carbon material, and ideally from the most abundant bacterial source possible. And we'd already kind of studied a lot into some of the toxicity in the food chain and everything else, and it was clear that it's hard to find live soil on the earth. So we dove back in time to the fossil layer that has soil that's now been sitting there for about 50 million years. And in that layer where we see these very, very thick layers of fossil soil that came from what looks to have been topsoil levels that were far deeper than anything we've got on Earth today, we started extracting these carbon-based molecules. And with that experience, as we put that into play in microscopes, we saw extraordinary things happening that have really never been explained before or actually witnessed before. And a lot of this came down to communication, not just between the bacteria and fungi, but actually this incredible direct talk to the mitochondria within the human cells, modifying their metabolism, modifying their redox signaling potential, etc., as well as reducing stress within the healthy human cells by removing some of the most kind of oxidative or damaging hydroxyl free radicals from the body and others. And so by taming some of the kind of inflammatory cascade simply by providing communication was a huge, huge, fascinating journey. And what we ended up finding was that indeed this communication network from the soil has the ability to turn on the human genome to produce an enormous amount of extracellular matrix. And in an era where we have chemicals steeping our food that are destroying that extracellular matrix, those tight junctions and beyond, this becomes a huge critical missing ingredient in this human health and foundation for longevity.
So let me just summarize, and then you could fill in the pieces. So what you created through essentially this ancient dirt or soil is what you call restore, and restore sets up or renews or refurbishes the communication network in your microbiome so your microbiome can then thrive again and function the way it was intended. Is that fair?
That is good. Yeah. I mean, this is very much like wireless communication networks is a good way to picture redox signaling molecules. So we're talking about cells, but let's shift for a moment to your cell phone. Your cell phone has a computer in there that receives and transmits information all the time. And it has the potential to connect you to any human on the planet at any time that has another cell phone. And so this is an extraordinarily powerful communication tool. However, if you're more than 7 miles away from the nearest cell tower, that thing is rendered useless as a communication tool. And nothing is broken in that phone. The same receiver, the same transmitter's there, it's sending out the same signal. The only difference is it's lacking this extracellular communication network, which is the wireless phenomenon that we have around us. It's exactly the same phenomenon of these redox signaling molecules outside the cells. The cells are trying to talk across large distances all the time. This is the communication, wireless communication, that puts that into motion. And more importantly, perhaps, or equally as important at least, we see that with the support of the tight junctions and the gap junctions, which look like fiber optic cables running between our cells, the support of that from Restore is perhaps even more profound in that it's now supporting not just the extracellular environment of redox signaling, it's now supporting the direct communication of intracellular or mitochondrial sourced redox signaling as it shoots through these fiber optic cables from one cell to an adjacent cell to ultimately to a whole string of parallel cells that are communicating across distances.
So, Dr. Butch, let's just go a little bit, I guess practical would be the word, to any level you're comfortable with. What are you seeing clinically or how are people clinically benefiting from Restore?
Sure. Yeah, it's notable that this is probably the most FDA compliant compound on the planet. The FDA, as you know, regulates the claims that are made by dietary supplements, and so all dietary supplements are not allowed to claim that they diagnose, treat, change the course, or help prognose any disease or disorder out there. And that's exactly why Restore is so profound, is it actually doesn't do any of those things at all. It actually is just like the wireless. The wireless tower is never initiating a message. You never get a phone call or a text message from the wireless tower near you. You're getting it from somebody else's phone, some other cell distant, that's now transacting that communication through the wireless network. In the same way, Restore is simply there in a passive fashion to absorb and transmit the signals from one cell to other distant territories. And so with that pattern going, you've got a really benign environment or benign therapy in that you've got this extraordinary situation where if you could just put a secure wireless network across the whole globe that no cell phone ever dropped, you would get perfect communication. Of course, all of us experience frequent drops in our cell phone coverage and everything else because we go around a corner or we get a little more distance. That, I believe, is starting to happen with increased frequency in the human body. The human body is dropping these signals out as from one cell to the next as these chemicals move in that are breaking the extracellular matrix, and so breaking tight junctions, gap junctions falling apart. We now are losing that cell-to-cell communication, and as the bacteria and fungi die out, we're losing this extracellular reporting system or communication network that we would expect to be made from our own microbiome. And so the results in the clinic are very apropos to that description. What would you expect to see if suddenly all of your cells started communicating? Well, that's going to depend on exactly kind of what health level you're in. At optimal health, where you're just clicking along and you've got kind of the normal changes of aging but nothing else going on, it's going to be relatively subtle. And the main difference is going to be that the aging process from one day to the next might be slower. You're literally just changing that natural decay and communication that leads to the aging process. If you shift that by just boosting the wireless signal, now you're just waiting for the messages to come across, and the body is going to start catching that any decline much quicker and more thoroughly, to replace, to exchange, to repair, to turn over the cells. All of that's being done by your own body's natural mechanisms, not by Restore. Restore just happened to get the word out or get the word to the cell that needed to make the change. So what we see in clinic is a steady youthification, if you will. All of us age chronologically at the same rate, but biologically you've witnessed, whether you're a doctor or not, an enormous difference in the rate at which people age. I'm sure you guys have met 80 and 90-year-olds that look like they're 60. Right. I'm sure you've met 40-year-olds that look like they're 60. And so we can age faster, we can age slower based on our biology. And so that's exactly what this communication network supports, is how slow can we go on the aging process, how fast can we speed up cell communication, therefore cell repair, cell transfer, cell replacement, all of these different mechanisms of youth that happen in our body every day. And so it's an exciting thing when you see healthy people getting healthier over time, healthy people not only plateauing their previous decline, but now actually setting goals and targets for becoming stronger, faster, smarter every year rather than expecting decline. Not because Restore is making them younger, because their body's already equipped to be young. It just needed to hear the message that they're damaged here or they have issues there. They needed to be able to respond to that. My hospice experience is pretty interesting. I've got a lot of patients that make it over 100 years old. And when you're looking at a 100, 105-year-old patient, you have huge respect for the human journey. They have incredible stories and amazing spirits in those bodies. But the profound thing is when you see somebody like that and you start to think about their cell biology, every single organ in one of my patients who's dying at 105, all of those organs, the pancreas, the liver, the kidneys, the brain, all full of stem cells ready to replace any damaged tissue. So the fact that we're even capable of dying of quote-unquote old age is indicative of just how bad this communication can break down, that we have all the machinery sitting there to repair and replace, and it's not mobilizing, and so we just start aging because we're not turning on our mechanisms of youth, we're not turning on our machinery for repair, and we start to plateau and decline and decline, and we put that communication network back into place, and you're going to see a shift. You're going to see that shift happen. For some people, it's within minutes. We've had many elderly patients and kids shift, their verbal scores and their cognitive function and everything else within minutes as the wireless network goes back up. Again, it's not treating a darn thing. Your body was just simply equipped to be younger. It just needed to know that it needed to mount this response.
And in the Restore product, it's a liquid. It's nearly a tasteless liquid. Something that I just bought and been using for about 2 weeks. You have a nasal spray as well to support that the nasal microbiome. Are you at liberty to? Are there any other new products on the way other than these two main core products?
These are our core products right now. We have products coming out for the pet line. LumaPet is the product for pets. It turns out pets have a much higher amount of Roundup in their feed than humans do, and so they've been hammered with all kinds of dysfunction and disorders. Their food has declined faster than ours. So we have a whole line of dietary supplements to help support their gut and vascular trees and everything else. We've got a line for that's coming out in the coming year through Canada first and then the U.S., but we've actually gotten approval from the FDA or the version of the FDA in Canada there to move into large-scale clinical trials for the beef industry and then moving into the poultry and pork to try to improve the health of these animals, to try to decrease the amount of stress that's being passed from those animals into our own bodies when we consume stressed out meat. That affects our microRNA. It turns on stress in our bodies. And so we think there's a lot of indirect methods for hitting the human by now, moving products to improve the health and reduce the stress of these animals as they're in the food chain. And so we have a lot of excitement about that. Back on the human side, we've got a line of detox effort that we're working on for the coming year. So lots more to come on the mitochondria and beyond.
I've also heard of a rumor of a potential book. Is that also a possibility?
Mm-hmm. Yeah, the book is always that possibility that kind of lingers out there. Anybody who's ever written a book knows how that project can loom into the future, into this gray zone. But success is its own enemy to book writing, I think. So I'm spending so much time running around the country teaching that I can hardly have time to stop and actually type something. But the book will be coming out this year is the expectation, and we look forward to sharing that with your audience.
Yeah, well, once it does come out, I can reach out to your team and you'll hop back on for sure.
I would love to.
All right, great. So, and I'm sure that the audience got this from your talk, presentation, whatever you want to call it today, because it was unbelievable. Is that this is such a unique, different, and novel way at looking at health, wellness, the microbiome, longevity, disease, that every time I hear it in a little bit of a different way that you present it, it just astounds me. And I thank you for being who you are and what you're bringing to the table for sure. So my final question, essentially, that I ask every guest, and it's kind of a fun question, is that what does Dr. Bush's day look like from waking to sleeping? Not necessarily when you're on the lecture circuit, but just kind of, affirmations, visualizations, supplements, exercise routines, family time. Like how does your day look?
Yeah, it certainly changes every day, which is one of my favorite things about it. I think variety is the spice of life. But I live in the woods in Virginia, which is such a gift. I usually wake up to the sound of dawn hitting, amazing amount of birds and wildlife in my woods. And so I always feel like I'm waking with the planet, not just to my alarm. And that's, I encourage you to, if not in your daily life, if you're in a suburb or somewhere where you're isolated from nature, to look for opportunities to experience that on some sort of regular basis, whether that's camping or getting to the beach frequently or whatever it is. But the opportunity to wake up with the planet is an extraordinary reminder of just the reality that we're just a pinpoint in this beautiful tapestry of life around us. And it changes the way I live the rest of my day, which is, instead of being, absorbed in my to-do list and everything else, it's really about that initial realization of, man, what a gift to be alive, what a gift to be part of this extraordinary web of life around us, to be one with the microbiome that lives within me, without me. I breathe it, I touch it. It supports me on every avenue. And then the next major piece of it that's led to my biggest success in life, which I really encourage everybody to do, is to eliminate from your beginning of the day expectation. If you just stop, with your to-do list and the expectation that you're going to finish your to-do list, you're going to reduce your stress levels massively. But way more importantly, you're going to open yourself up to the creativity of the universe. I really believe that the intelligence around us, whether you call it God or universe or however you see it, there is a play at work here. There is absolutely this extraordinary ballet being dictated around us that we participate in. And when we take it from our limited human perspective, and we decide to set out into every day with, I need to do this, this, and this, and if I don't get that done, damn it, I didn't do it again, and I failed, and blah. We completely disrupt the flow of the ballet that is already planned out. There's going to be things brought into your life every day that you can't see coming, and those will be blessings, they'll be challenges, there'll be, hurdles for you to jump over, there'll be unexpected, gifts that will come. All of this stuff will be recognized better when it comes and will be responded to more appropriately if you've started the day with an expectation of adventure rather than an expectation of expectation.
That is one of the greatest answers we've ever gotten. Audience, all the links to Dr. Bush's website and to the product or store can be found in our show notes. My name is Dr. Noah DeCoyer, your co-host, and you are listening to the Beyond Your Wildest Genes podcast. If you'd like what you've heard today, please share this with your friends and encourage them to subscribe on iTunes. Leaving a review and rating on iTunes helps us move up the charts and helps more people find us. You can subscribe to our incredible weekly email at www.beyondyourwildestgenes.com. Thank you, and as my oldest son Hayden says, be awesome and never unawesome. Thank you, Dr. Bush.
Thank you for having me, Noah.
Hello, it's Dr. Noah, and I'm back. I suspect you loved listening to this week's podcast release. Our book of the month is simply incredible, and in our estimation, a book everyone needs to read. Cancer and the New Biology of Water by author Dr. Thomas Cowan should be on your super short list. Dr. Cowan has been on our podcast twice, once to talk about Dr. Cowan's garden, his nutrient-dense, nutrient-diverse vegetable powders, and most recently on November 11, 2019, to discuss his newest book. The link to purchase the book will be in our weekly newsletter and on social media, posted and sent throughout the entire month. Our product of the month is the Joovv red light therapy device. Photobiomodulation has been shown to assist with pain and inflammation release, fitness training and muscle recovery, and hormone regulation, to highlight a few of its near countless benefits. As I mentioned, I own a Joovv Mini and Joovv Go and use them every day. My skin has never looked better, and I certainly recover faster from my workouts. On October 8th, 2018, I interviewed the co-owner Scott Nelson. I highly encourage you to listen and learn more about all the benefits of red light therapy using the Joovv. The supplement of the month for February 2020 is vitamin D3 Boost. It is pretty mainstream now how important vitamin D3 is to your overall health and wellness. What is not mainstream is the nutritional facts that vitamin D3 needs a few other cofactors, vitamins, and minerals to enhance its effectiveness. Recognizing this, we set out to formulate the gold standard for vitamin D3 supplement. Vitamin D3 Boost has the most active form of vitamin D, as well as vitamin K2, magnesium, and a little bit of MCT oil to enhance the absorption of these fat-soluble vitamins. This is truly a world-class vitamin D3 formulation. You can check out the spec sheet and research articles on our website. The 10% discount code for the month of February, and remember, it's case sensitive, it's VITD10. Thank you for your time. Thank you for listening, and be awesome and never unawesome.